Okay, in this video, we're going to do section 3.3, number 34. And in this problem, we're asked, when does this graph have a horizontal tangent line? And so we go ahead to find the equation of the tangent line. You must at least know the derivative. And in fact, asking when f has a horizontal tangent is actually asking when is f prime of x equal to 0. So we're going to go ahead and find the derivative here. F prime is equal to, well, this is a product rule. Derivative of the first is just e to the x times the second, plus the first times the derivative of the second. Well, the second would be a cosine. Derivative of the cosine is a negative sine. And now we factor out the e to the x, and you see we have a beautiful cosine of x minus sine of x as a factor. And we want this to be 0. Well, this function is 0 when either e to the x is 0, which never happens, or when cosine minus sine is equal to 0. So we need to solve cosine of x minus sine of x is equal to 0. Again, that'll give us the values for which the derivative is 0, or in other words, f has a horizontal tangent. Now there's a couple ways to do this. I will probably just do it the easiest of ways, which is adding sine of x to both sides. And then you could divide by cosine of x. However, if you divide by cosine of x, you have to worry about cosine of x being 0. And of course, if cosine of x is 0, so a little side note here. The reason why I'm saying this is because a lot of students tend to divide by expressions that involve variables, and you cannot do that if you do not know that that variable expression is 0. So here we're just going to mention, if it were the case that cosine of x were equal to 0, then we happen to know, because the cosine curve, x would have to be either pi over 2 or any pi rotation thereafter. So pi over 2 plus pi, which would be a 3 pi over 2, and then another pi would be a 5 pi over 2. At all those values, the cosine is actually 0. And by the way, this is where k is an element of the integers. Well, if you consider any odd multiple of pi over 2, which is what this would give us, sine of x would be, well, non-zero. This is the most important part. But at odd multiples of pi over 2, sine is either 1 or negative 1. And so it's definitely non-zero. So if cosine were 0, sine would not be 0, and therefore this equation here would not be true. So I know that I can divide both sides by the cosine, is basically what I'm saying here. So that will imply that 1 equals sine over cosine. Or in other words, tangent is equal to 1. There are a few other ways you could solve this, but I think this is the best, actually, way to do this. And then I know tangent is 1 when x is equal to pi over 4. Also, well, that's a quadrant 1 solution, but it happens to also be positive 1 at 3 pi over 4 in quadrant 3. And then, therefore, any pi distance away from that, or rotation thereof, k is an element of the integers. So that's a way you could do this problem. There are actually several different ways, but I think that's probably the best way.